doing a long multiplication problem over here. You're doing a distributive function. Okay? Now, how would that show up on the calculator? Just to show that we did the right things in here. Just if you don't believe me that that's the value we're going to get, let's come back and look. We have two matrices. Our first matrix is how large? One row, 3 columns. Does the template look right? And the numbers respectively are 2 and -3 and 4. And we're done with that matrix. What's our second matrix look like? It's 3 by 1. Template look right? The format look right? Its cells values are 3, 5, and -1. And if we told the calculator that we wanted to take matrix number 1, the 1 by 3, and multiply it by matrix number 2, matrix number 2, same thing that we got, right? Multiplying matrices is one of the problems that you're going to see on the test that will say, do it by hand. First 2 workbook pages. The last problem on each page is multiply these 2 matrices, show the intermediate step, do it by hand. Only they aren't always going to be small and like this. They may get to be a little bit larger. Okay, so larger matrices just means we have more repetition. That's all it really means. So what is the size in our second example? How large is the first matrix? What's its size? 2 by 2. How large is the second matrix?
2 by 2.
Also 2 by 2. Could these 2 matrices be added together? Yes, they could. Could these 2 matrices up here have been added together? No, they could not, but they can be multiplied. Okay, so if you multiply these 2 matrices together, this is the first thing you look at and say, are these things equal? If that tells you yes, then that means the operation is defined and you can proceed. What kind of a result are you going to get? A 2 by 2 matrix. If this is rows, columns, then if these 2 values have to be the same, and they are, then look at the end of the problem. You have 2 rows and 2 columns. So you're going to end up multiplying several rows by several columns. Row 1 has got to be multiplied by column 1. Row 1 has to be multiplied by column 2. And then you're done using row 1. Row 2 has to be multiplied by column 1. And then row 2 has to be multiplied by column 2. Every row is multiplied by every column. 2 rows, 2 columns, 4 distinct different multiplication steps. Bigger matrix, more steps. Now it's a matter of executing. First element in row 1 is multiplied by first element in column 1. Added to first element in row 1. Second element in row 1, because we never reuse an element, multiplied by second element in column 1. First element by first element, second element by second element. Never using the same elements on more than one item in the column. Row 1 is also going to be multiplied by column 2. So now we're going to be shifting and looking at the first row and the second column. first element in row 1, -2, multiplied by first element in column 1, which also happens to be a 7, plus second element in row 1, which is 3, multiplied by second element in column 1, which is, in column 2, excuse me, which is -1. Now I've done all of row 1's multiplication. And now I go to row 2. Row 2 now is going to be multiplied by column 1. First element in row 2, 4. First element in column 1, 7. Second element in row 2, 5. Second element in column 1, 6. Row 2 now gets multiplied by column 2. First element in row 2, 4. First element in column 2, 7. Second element in row 2, 5. Second element in column 2, -1. This is your middle step. You're not obligated to do much more by hand, but you could if you wanted to, because -2 times 7 is a -14. -14 added to a +18 leaves me a value of a +4 as the result of the upper right-hand cell. -2 times 7 leaves me again a -14. 3 times a -1 leaves me a -3. -14 and a -3 is a -17 in the upper right-hand cell. 4 times 7 is 28. 5 times 6 is 30, leaving me a 58 in the lower left-hand cell. 4 times 7 is still 28. 5 times a -1 is a -5, leaving me 23 in the lower right-hand cell. This process of multiplication is more tedious and would be encouraged to check it on the calculator. That would mean you'd put in matrix 1 as a 2x2, matrix 2 as a 2x2, and you'd proceed. So let me show you the other thing that I have to do before we leave this particular set, because that's almost the last one that was there. When we look at matrix operations,